Okay, so let's look at graphing the log of a quadratic. And some features you always want to start with, really for any graph, but particularly for these log graphs, are domain and range, any asymptotes, and the intercepts, x and y. And then we'll see if we need more. Often we don't need more than that to get us just a general sketch of this graph. Okay, so for domain, remember you can only take a log of positive values. You can't take a log of 0 or negative. Why is that the case? Well, consider if we just had y equals log base 2 of something. I'm just going to put blob or whatever, cloud. So this means 2 to the y equals that something. Well, there's no way that something could be 0 or negative. So thus, inside a log has to always be greater than 0. Okay, so so for the domain, first thing we're going to do is we set up the inequality that the inside has to be positive. And in this case, luckily, I can actually factor this. So, and which allows me to put things on a sign chart. And you can either plug in values or you can recognize the fact that this was a quadratic that we're looking at that opens up. And where is it positive? On the extremes. Okay, so my domain here is negative infinity to negative 2 exclusive. Maybe, remember, inside the log can't be 0. Now for the range. The big things with logs, normally if you just had a standard like y equals log base 2 of x, remember the range, the y value here stands for the exponent. If we think of exponential functions, right? So this just means 2 to the y equals x. So the range should be all real numbers. But that's not always the case. So you want to make sure that inside, in order to get all real numbers, you need the inside to go towards infinity. You also need the inside to get really close to 0, because how the output, which remember is the exponent, is going to be, in this case, negative infinity, is if the inside gets really close to 0. Because remember, 2 to the negative infinity is going to get really close to 0. But we know it goes really close to 0 because of our domain here, right? So we know that it's going to get really close to 0. So our range will be negative infinity to infinity. Another way to prove that to yourself is think about if we put in, let's rewrite this problem like this, y equals log base 2. I'm going to rewrite it in factored form instead of the original standard form the quadratic is in. So say I put in a value, say if I'm doing a table, say I put in like 6.0001, right? So this value here would be 0.0001, right? And this would be, I guess, 8.0001. And multiplying these two together, that's going to be a pretty tiny value. And 2 to what is going to give me a pretty tiny value? Well, it's going to be something decently negative. So that's how you can think about it if you want to guess and check. But the key is understanding the fact that you get towards negative infinity, or I guess it could be positive infinity too, depending on what the base is, but more on that later. When you are getting really close to 0, if inside can get infinitely close to 0 inside the log, which is the case here. All right, that was a long explanation of why for all reals. Now let's do y-intercept, because that's easier to find always. All right, what is y when x is 0? So nope, no y-intercept. Can't do a log of a negative, because 2 to the y can never be negative 12. No. All right, now it's x-intercepts are always a little bit more challenging. Oh, and then I skipped over asymptotes. I'll get back to asymptotes. So x-intercept is 0 equals log base 2, x squared minus 4x minus 12. Well, how do I solve for x here? You change it to exponential to 2 to the 0, which is 1. And yeah, you usually pray you can factor it. I feel like it seems often you can't. So then, unfortunately, we've got this quadratic formula. Well, fortunately, we have this. Maybe people think it's unfortunate because it usually can be a little bit messy. But so b squared minus 4 times a times c over 2a. But hopefully it'll be simple enough so we can estimate these x-intercepts. So this is going to be 16 plus 52, which is going to be 68. So 4 plus or minus 2 can come out. So this is going to be 2 plus or minus root 17. Okay, so what is that about? Well, root 17 is a little bit more than root 16. So we're going to add a little bit more than 4. So let's just estimate that this is around 4.1. It's close enough. So 6.1 would be one x-intercept, and 2 minus 4.1 is negative 2.1. So these are about the x-intercepts. All right, well, let's put it all together. Oh, sorry, keep on forgetting vertical asymptotes. Vertical asymptotes always occur where the inside the log equals 0. And that goes back to what we were just talking about, how when you're taking log of something super close to 0, in order for that to happen, in this particular case, you need the exponent is going to be positive or is going to be negative infinity in this particular case. And vertical asymptotes, remember what occurs at vertical asymptotes. It's when the graph explodes either towards positive or negative infinity. And so that it will do that when inside the log equals 0. So my two vertical asymptotes are 6 and negative 2. All right, so that should be enough to put this all together. All right, so I always put my asymptotes first, if there are any. 1, 2, 3, 4, 5, 6, okay, and then negative 2. And no y-intercepts, which makes sense because the domain does not include when x is 0. So I'm on the outside here. So I've got about 6.1. Actually, it's even closer. And negative 2.1. And remember log graphs, slow growth. So you can plot points, but honestly, no need. No need to plot points here. Just recognize the fact that log growths are that slow growth. We just want that general shape. Okay, let's do something that similar in the fact that there's a quadratic inside, but has a very different look. Okay, this is going to be k of x then on. So this is k of x on 5.5, I believe. No, 5.6. All right, k of x is log base 2 of negative x squared plus 2x plus 63. All right, here we go. Domain first. So need inside to be greater than 0. Let's see if we can factor. I never factor with a negative quadratic. So I'm a negative coefficient of the quadratic term. So I'm going to take that out and see if I can factor. Yes, I can. 9 and 7. So I can do sign analysis. Remember, it's a quadratic that opens down. So it equals 0 at 9 and negative 7, which is also helpful because those are going to be my vertical asymptotes. Okay, so the domain here is going to be, oops, what am I doing? Domain is negative 7 to 9 exclusive. And I'm also going to just make note that my vertical asymptotes, where the inside equals 0, are negative 7 and 9. Okay, the range is a little challenging here because I know it's not going off the inside of the log is not going towards positive infinity because the inside of a log is a parabola that opens down. So it has its limitations here. So again, think about the range of the inside of the log, and then we'll apply log base 2 to that. Okay, so the range of the inside of the log is to find the range of this quadratic that opens down. I know the low is going to be 0, right? Or as close to 0 as possible. And the high, though, I need to find the y-coordinate of the vertex. So the x-coordinate of the vertex is negative b over 2a, so negative 2 over 2 times negative 1, which is 1. And the k value is plugging it back in. So I've got negative 1 plus 2 plus 63. So 64. Oh, that's nice. All right. So the high value is going to be 64. So now let's do this out. 2 to what power gets me really close to 0? Negative infinity. 2 to what power gets me 64? So that's going to be 2 to the 6. Okay, so that is the range there. And by the way, we could have done that if we go back to the earlier. I more kind of explained it conceptually, but it may be easier to think about when you do the range of this quadratic. Again, going back to what we knew was the domain, you're doing log base 2 of 0, and I know it goes towards infinity. So thinking about 2 to what power gives me 0, negative infinity. 2 to what power gives me infinity? Infinity. So again, doing the range of what's varying, which is the parabola in both these problems, then helps you to find the range of the whole problem. Okay, should have probably done that from the beginning instead of explaining all the logic, although I was using it to help explain also the vertical asymptotes, but okay. All right, so now we have our range. Okay, and y-intercept, x-intercept. So y-intercept is y equals log base 2 of 63. All right, so it's a little bit less than 6, right? So we're going to say little less than 6, because 2 to the 6 is 64, and this is a little bit less than that. So the y-intercept, I would just write 0 log base 2 of 63. And the x-intercept, okay, I have a feeling this is going to be less fun, but so to find the x-intercept, set y equal to 0. So 1 equals negative x squared plus 2x plus 63. So 0 equals negative x squared plus 2x plus 62. Oh boy, yeah, not looking good. All right, so let's do the quadratic formula. So x equals negative b plus or minus b squared minus 4 times 1 times 4 times negative 1, whoops, times 62 over 2 times negative 1. So x is negative 2 plus or minus, so let's see, we're doing 62 times 4, 248 plus 4. So plus or minus 252 over negative 2. All right, and let's see. Yeah, 4 is going to go in there. So negative 2 plus or minus, take out a 2. So we've got 63. Something else can come out of there. So then I can also take a 9 out. So it's negative 2 plus or minus 6 root 7 over negative 2. Or in other words, this is equal to 1 plus or minus 3 root 7. Okay, so root 7 is between 2 and 3. So let's just call it 2.5 for now. Or actually, I'm going to call it about 7/2. So we're calling about 7/2, this root 7. Okay, so this is a lot of work for x-intercepts here. 1 plus or minus 21 halves, or in other words, think about it as 1 plus or minus 10 and a half. So that will be, wait, something is not right here. That does not seem right. So let's back up and make sure that we did these x-intercepts correctly. 8, 248 plus 4, 2 to the 0 is 1. Bear with me for a second. Negative b. All right, hold on 1 second while I try to figure out, because something doesn't look right here. Oh, I see what I did here. I said 2.5 was 7 halves, which is not the case. So, all right, that's where that looked way too big. Okay, so this, we said it was between 2 and 3. So I said, let's call it about 2.5, which is 5 halves. So this would be about, if I make this a fraction, this would be about 15 halves. So, all right, or when I multiply 5 halves times 3 would be 15 halves. So, or we're doing 1 plus or minus, I think 7.5. So the 2 are about 8.5, or negative 6.5, which makes way more sense about. Okay, you'll see why the other didn't make sense and how I could right away tell. It was because where our asymptotes are and what our domain was. So when we put this all together, we said the asymptotes are, let me go back here, we're at 9 and negative 7. So it's 9 and negative 7. So this is x equals 9, x equals negative 7. We said the x-intercepts are about 8.5, so decently close there, and negative 6.5, all right? And then the other thing you do want to plot is the fact that your highest point is, when does it reach the highest point of 6? Well, it reaches that highest point, remember, of the vertex of the parabola. And what was our vertex? If we go back, what our h value was, it was 1. So 1, and that highest value was 6. And how do I know it goes towards negative infinity? Because it's a vertical asymptote, so it has to go either towards positive or negative infinity. And I know it doesn't go towards positive infinity because of my range. I know the highest point is at that 1, 6. So as you can see, there's always one tedious part. It's usually the x-intercepts, if there are x-intercepts. It just ends up having to do the quadratic formula. And of course, sometimes you make an error, which luckily you would have caught here too if you had made the same error as me, because it would have made sense for it to have this highest point and then go across the vertical asymptotes. Okay, that's it.